Good day, my dear learners. We are going to learn about identifying the forms of quadratic functions. Good morning once again. We have the standard form, and the standard form of any quadratic function f of x is equal to ax squared plus bx plus c. So when you see any function or equation in this form, then it tells you you are dealing with quadratic, either equation or function. So example of a quadratic in the standard form is f of s equals 2x squared minus 4x plus 5. When you compare it with the standard form, our a is 2, our b is equal to -4, and our c is equal to 5. The a has been bolded because it has a function to play when it comes to graphing, of which we may consider. Then example 2, y equals -2x squared plus x minus 3. A is equal to -2, b equals 1, because in front of the coefficient of x here is 1, and c is equal to -3, with a being bolded once again here. Then let's look at the vertex form. For the vertex form of any quadratic function, f of s is equal to a bracket open x plus h bracket close squared or raised to the power 2 plus c. So when you see any quadratic in this form, it is in its vertex form. Example, f of s equals 2 bracket open x minus 1 bracket close raised to the power 2 plus 3. The a is what comes in front of the brackets as compared to the standard form, the vertex. So as compared to the vertex form, so our a is 2, the h is -1, and c is 3. The a is very essential in graphing. That's why it has been bolded. Example number 2, y equals negative bracket open x minus 1 bracket close raised to the power 2 plus 5. The a equals -1. So in front of the bracket is -1. If it were to be above 1, then it would be written, but because it is 1, that's why only the negative is seen. Our h is -1 and c equals 5. Still, our a is very essential for us in graphing, so it is also bolded. Now, these are the only two forms you may find in WASI, where or in your exams, where either the quadratic function would be given in the standard form or it would be given in the vertex form. When you see them, you have to be able to identify that this is a quadratic function or equation and so on. Again, when you see y equals, we all know that in functions f of s, if the name of the function is f of s or h of s and so on, they can be written as y equals. So that's why you see y equals and at times f of s equals. So don't be confused. Now let's look at the nature of the graph of a quadratic function. That's where the A comes in. The nature of the graph depends on the A. If A is less than 0, it means that when A is a negative number, any number less than 0 is a negative number. When it is less than 0, that is when it is a negative number. Example, y equals negative 2x squared. The A is negative 2. In the second example, f of s equals negative bracket open x minus 1 bracket close raise the power 2 plus 5. Our E is negative 1. Because this is the first one is a negative value and the second one is a negative value, their graph may open downwards. As you see, the nature of the graph would open downwards. Negative is spelled as n, so the small n, how it looks like is how your graph would look like. Then if a is greater than 0, meaning when a is a positive value like 1, 2, 3 and so on, then taking an example like f of s is equal to 2x squared minus 4x plus 5, which has a to be 2, and y equals 2 bracket open x minus 1 bracket close squared plus 3, where the a is also 2. They are all positive values. Then our graph would open upwards. That is, the shape would look like U. When you know this, then when you are given any table to fill and to use the values to draw a graph, after graphing you should be able to tell either you are correct or wrong. So to be able to identify that your graph is correct or wrong, you should know this, so that even before you draw, looking at the function, you will be able to tell that, oh, for this graph it would look like n or it would look like u. May God be with you all till we meet again. Bye.